Hey everyone, it's your friend Development Interview Prep, and welcome back to the channel. We are here with the part 2 of the JavaScript interview questions and answers. Today, we're diving deep into the world of JavaScript to equip you with the knowledge to conquer those challenging coding interviews. We'll be tackling some of the most common and sometimes tricky JavaScript interview questions. I'll break down each concept in a clear, concise way, so you not only understand the what, but also the why behind it. So grab your favorite drink, get comfy, and let's get started. Alright, let's start with, what are JavaScript generators? Now imagine a function that can pause, like hitting a pause button in a movie. That's essentially what a generator does. It's a special kind of function that can pause its execution and resume later when needed. The magic word here is yield. Whenever a generator encounters yield, it spits out a value and pauses execution. Think of it like a vending machine. You put in your code, request, and it yields a value, your snack. Now let's visualize this with a simple example. We'll create a generator function that yields a sequence of numbers. Don't worry, it's not as complicated as it sounds. Next up, what is currying in JavaScript? We have currying, a technique that might sound like something you do in a kitchen, but trust me, it's pure JavaScript magic. Basically, currying lets you transform a function that takes multiple arguments into a sequence of functions, each accepting only one argument at a time. Think of it like ordering a pizza. Instead of giving all your toppings at once, you could tell the chef, I want pepperoni, then add mushrooms, and finally extra cheese. Each step adds a layer of flavor, or in our case, functionality. Currying can make your code more readable and reusable. Let's illustrate this with a real-world example. We'll create a curried function to calculate the discounted price of an item. Now let's unravel the mystery of the JavaScript event loop, the engine that keeps your code running smoothly. You see, JavaScript is single-threaded, meaning it executes one task at a time. But how does it handle tasks that take time, like fetching data from a server? That's where the event loop comes in. It's like a tireless waiter, taking orders, your code, and delegating them to the kitchen, the browser's web APIs. In the meantime, it keeps serving other customers, ensuring a smooth flow. When a long-running task is complete, like that data finally arriving from the server, the event loop places it in a queue, the callback queue. Once the main thread is free, the event loop picks up the completed task from the queue and executes it. Let's see this in action with a simple example using setTimeout. This will demonstrate how the event loop manages both your immediate code and delayed tasks. Object.freeze versus object.seal, freezing and sealing your objects. In JavaScript, we often deal with objects, those flexible containers holding our data. But what if we want to restrict how these objects are modified? That's where object.freeze and object.seal come in handy. Think of object.freeze as putting your object in a block of ice. You can look, but you can't touch. It prevents any changes to the object's properties. No adding, deleting, or modifying. Object.seal, on the other hand, is like sealing your object in a plastic bag. It prevents new properties from being added but allows existing properties to be modified. Let's solidify our understanding with code examples. We'll create an object and then apply both object.freeze and object.seal to see their effects. What is the async await syntax in JavaScript? Async await, the elegant symphony of asynchronous JavaScript. Asynchronous JavaScript can be a bit like a jazz improvisation, exciting but sometimes unpredictable. That's where async await comes in, providing a cleaner, more readable syntax for handling promises. Think of async as a backstage pass to the asynchronous world. When you place it before a function, it tells JavaScript, hey, this function will be dealing with promises. Inside an async function, you can use await before a promise. Await acts like a patient waiter, pausing the execution of the async function until the promise is resolved. Once resolved, it gracefully hands you the resolved value. Let's compose a beautiful async await symphony with a practical example. We'll fetch some data from an API and handle it elegantly using this powerful syntax. Chapter 6. What is the difference between for of and for of versus for in iterating with purpose? In JavaScript, we often find ourselves iterating over collections of data. Two common ways to achieve this are the for of and for in loops. While they might seem similar, they serve distinct purposes. Think of for of as a guided tour through the values of an iterable object, like an array. It's like visiting each landmark on a sightseeing tour, focusing on the sites themselves. For in, on the other hand, is like exploring a museum with a map. It iterates over the innumerable properties of an object, giving you the keys to unlock the treasures within. Let's embark on a coding adventure to see these loops in action. We'll use for of to iterate over an array of fruits and for in to explore the properties of a fruit object. What is a JavaScript prototype? JavaScript prototypes, the blueprint of objects. In the world of JavaScript, objects inherit characteristics from their blueprints, prototypes. Imagine a prototype as a master template that defines the structure and behavior of objects created from it. Every JavaScript object has a prototype, a hidden link to another object from which it inherits properties and methods. It's like a family tree where objects inherit traits from their ancestors. This inheritance allows us to create objects with shared functionality without writing redundant code. It's like baking cookies from a cookie cutter. Each cookie is unique, but they all share the same basic shape. Let's bake some code to illustrate this concept. We'll create a car prototype and then create instances of cars, each inheriting the properties and methods from the prototype. What is throttling in JavaScript? Throttling in JavaScript, controlling the flow of events. Imagine a busy intersection with cars zooming by. Without a traffic light, chaos would ensue. That's where throttling comes in, acting as a traffic cop for your JavaScript events. Throttling limits the rate at which a function can be executed. It's like setting a speed limit on a highway, ensuring a smooth flow of traffic, or in our case, events. For example, when handling scroll events, you don't want to bombard the browser with hundreds of events per second. Throttling allows you to control the frequency, say, executing a function only once every 250 milliseconds. Let's implement a throttled scroll event handler to see how it can improve the performance and responsiveness of your web applications. What is debouncing in JavaScript? Debouncing in JavaScript, taming the input frenzy. Picture a search bar where every keystroke triggers an instant search request. It would be like sending a search party for every letter you type, inefficient and overwhelming. Debouncing comes to the rescue, acting as a gatekeeper for your input events. It ensures that a function is executed only once a burst of events has settled down, like waiting for a calm moment before sending that search request. Imagine you're typing a word in a search bar. Debouncing allows you to wait for a brief pause, say 300 milliseconds, before initiating the search, preventing unnecessary requests. Let's build a debounce search bar input handler to see how it can make your applications feel more responsive and user-friendly. What are arrow functions and how are they different from regular functions? Arrow functions, the shorthand for JavaScript functions. JavaScript loves to provide us with elegant shortcuts, and arrow functions are a prime example. They offer a more concise syntax for writing functions, especially when dealing with callbacks. Think of arrow functions as the cool, compact cousins of regular functions. They ditch the function keyword and often omit the curly braces and return statement for single-line expressions, but there's more to them than meets the eye. Arrow functions have a lexical this binding, meaning they inherit the this value from their surrounding context. Let's compare arrow functions with regular functions side by side to see their differences in action. We'll also explore how their this binding behavior can be quite handy. Provide code examples to illustrate the differences between arrow functions and regular functions. What are promises in JavaScript? JavaScript promises, navigating the asynchronous seas. In the world of JavaScript, we often encounter tasks that take time to complete, like fetching data from a server. Promises are our trusty ships, guiding us through these asynchronous seas. A promise represents the eventual outcome of an asynchronous operation. It's like a promise from a friend to bring you a souvenir from their trip. It can be in one of three states: pending, which is still traveling; fulfilled, meaning it brought the souvenir; or rejected, when something went wrong. Promises provide a clean way to handle the results of asynchronous operations, avoiding callback hell. We can attach then handlers for success or catch handlers for errors. Let's embark on a promise-based journey. We'll simulate an asynchronous operation and handle its resolution and rejection using the power of promises. What is event delegation? Event delegation, the power of one listener. Imagine having to attach an event listener to every single item in a long list. That's where event delegation comes in, wielding the power of one listener to rule them all. Event delegation takes advantage of event bubbling, the phenomenon where events bubble up from the target element to its ancestors in the DOM tree. Instead of attaching listeners to individual elements, we attach a single listener to a common ancestor. Think of it like having a receptionist at the entrance of a building instead of one at every office door. The receptionist can handle visitors for all offices, making it much more efficient. Let's build an interactive example to demonstrate event delegation in action. We'll create a list of items and handle clicks on them using a single event listener on the parent container. What is a closure in JavaScript? Closures, the secret handshake of JavaScript functions. Closures are one of those JavaScript concepts that might seem a bit mysterious at first, but once you understand them, a whole new world of possibilities opens up. Think of a closure as a secret handshake between a function and its surrounding environment. Even after the outer function has finished executing, the inner function still retains access to the variables in its outer scope. It's like having a private locker where a function keeps its belongings safe and accessible, even after it has left the building. This allows for data encapsulation and the creation of private variables. Let's unlock the secrets of closures with a practical example. We'll create a function that returns another function, demonstrating how the inner function maintains access to the outer function's variables even after the outer function has completed. And there you have it, folks. We've covered some of the most important JavaScript interview questions and concepts that will help you shine in your next coding interview. Remember, practice makes perfect, so keep coding, keep experimenting, and keep pushing your JavaScript skills to the next level. If you found this video helpful, give it a thumbs up, share it with your fellow developers, and subscribe to the channel for more awesome programming content. Good luck with those interviews, and I'll see you in the next video.